6-4, day 1. We're kicking off what we're calling chapter 6b. Let's see. Trig functions are still the focus, and actually graphing them is really going to be kind of the sole focus of 6b. It can be a little tricky, which is why it's only one learning target, and we separated it from the other 3, because this is really all we're going to focus on for the next couple of weeks, okay? And we had 6 trig functions. We're really going to look at how to graph 2, sine and cosine, okay? So that's how we're going to kind of narrow our focus. How do we graph the sine function and the cosine function? First of all, on this slide, let's make the jump to graphs, okay? Basically, here's what's going on, okay? You might be thinking, hey, wait a minute. This is trig. This isn't functions. Functions was last fall. What are we doing with functions? Well, okay, so we're in trigonometry, but you've heard us use that term before too, trig functions, okay? At their basic components, they're functions, right? In this sense, put in an angle and take the sine value. Think of the angle that you put in as x and y. That's what I mean by like their basic components, that they narrow down to the definition of a function, okay? I'll just highlight a few of them because you can see a picture of the sine curve down here. Okay, that point right there is saying at an angle of 0, sine is 0. Now you can see that this graph has a bunch of other points in between. Those would be like looking at these, right? Which I'm not doing. I'm going to go around and just look at all the quadrant points, okay? This is saying at pi over 2, sine is 1. Okay, remember you're looking at the y-coordinate on the unit circle. If we put in pi for our angle, sine is 0. If we put in 3 pi over 2, sine is negative 1. And if we get back to 2 pi, once again, sine is 0. Okay? And then you can see how the points fall in between to make this kind of interesting looking curve. It doesn't look anything like a function we saw first semester. But now we could keep doing that, okay? So if you see the term throughout the chapter, periodic, sine and cosine functions are periodic functions, which means they represent repeating patterns very, very well, because you can just keep going around the unit circle and the pattern that we see repeats. Same deal with cosine. All that happens now is I'm looking at the x-coordinate for the cosine value. I'll just highlight this first one, like right here. Notice the x-coordinate's 1, right? So when the angle is 0, cosine is 1. When I was doing the sine curve, I was looking at the y-coordinate. At pi over 2, cosine is 0. At pi, cosine is negative 1. Whoops, skipped one here. 3 pi over 2, cosine is 0, and then back at 2 pi. Once again, it's 1, okay? Very similar. Really notice the only difference is kind of where they start. Sine always starts right in the middle at 0, and cosine starts up at the top, okay? We really highlighted one period, okay? We highlighted one period there. Okay, you could certainly do more. You'll see on these graphs, the first couple of graphs that we're going to do together, I'll do 1. And then we'll kind of build up towards doing 2. Typically, if you're asked to like produce a graph, usually we talk about drawing 2 periods of the curve, okay? All right, first we got to talk about 2 components to allow us to stretch the graph out, because eventually, like we always do with functions, we want the data or the function to be able to represent some data. Okay, in this case, it would be periodic data that repeats. Okay, so we're going to get these measurements of A and B, right? amplitude is A, you would calculate it by max minus min over 2. So in other words, it represents half the distance between the max and the min of the function, okay? So here we're going to do a cosine curve, and we're just going to say that A is 2, okay? And again, here I'm just going to do 1 period. Okay, if you want to do it like a kind of challenge yourself, see if you can do 2 right off the bat, but I'm just going to draw in 1. Okay, with the cosine curve, it starts up here. I'm really just copying this from what we saw on the other slide. Bottoms out at -1, 3 pi over 2, back up to -1. Okay, that's just cosine. In fact, let me do this. Let's get rid of that. And this one I'll do in red. So now I'm going to factor in that the amplitude is 2. Okay? Now with this formula, you're going to see tons of 2's in here. Right? Your max is going to be 2, and your min is going to be 2. So this is really going to be the same curve, except we're going to stretch it out, not from 1 to -1, right? Because that blue is just a regular, unchanged sine curve. This one is going to head all the way up here. It'll still come down to pi over 2 at 0, but then the minimum will stretch down. Maximum will stretch up. That'll stay the same. So we made the top go higher, right? Again, we call that top the max, and the bottom go lower. We call that bottom, the minimum, okay? So we can stretch the function out, okay? Let's do another one with amplitude. Okay, so -1/2 sine x. So I want to split this part up into kind of 2 things. First of all, right here, A is a half. So this one is going to look a little bit different in the sense that it's not going to get like stretched out vertically. It's kind of going to get, it's kind of going to shrink. It's not going to go up as high or go as low, okay? Now we can't ignore that negative sign. That doesn't change at all. That's a reflection over the x-axis. So that's going to factor in 2. We'll see how that plays out. Okay. First things first, yet again, I'm going to put on my regular sine curve. Okay, that would start right here in the middle. Hit 1, come back to 0 at pi, down and there. Okay, that's sine of x. Saw it on the first slide. So -1/2, right? I'm going to get these marked right away that I'm expecting to go up to here and down to here. Going to go up to 1/2, down to -1/2. Okay. Now the other thing I got to factor in though is that negative sign. Okay, with a sine, we'll see one of each. Let me double check my notes here. Yeah, you'll see one with cosine too. Because cosine starts at a different spot. But with sine, you're always starting in the middle, but it means right away we need to go down. Okay, but at pi over 2, I need to go down. I don't want to hit -1. I need to stop at -1/2. And you would get something like that, okay? Goes down first and is kind of squashed, so it only goes between 1/2 and negative 1/2, right? So you kind of get the feel as you see a function that if you see a as a really big number, right, like 5, 6, 7, whatever, 20, you know the graph is really getting stretched out and is going to be like tall and skinny. And if a is really small, it's kind of getting compressed and it doesn't go that high or go that low, right? It gives us the ability, like whatever data we have, right? We haven't really talked about like, hey, what kind of data or what kind of situations would be represented well by periodic functions? Well, we'll get to that. But we could, it's nice that we can do either, right? We could stretch it out or kind of compress it. All right, the other thing that we can do, right, and there's technically more, but this is what I'm going to show you today, okay, is we can also change the period, which is how long it takes to complete one cycle, okay? Maybe put a note on here. You know, I'm just trying to keep it simple, and I'm talking radians the whole time. And you've seen this already come up today. Unless it's been changed, it's 2 pi, right? That's, you know, if you're doing like a trip around the unit circle in radians, that's where we're getting 2 pi. All right, if you want to change it, this number right here is known as b, right? Notice how it's inside the trig function with the x variable. Okay, now I'm calling it x just to kind of get it back into the notation that we would use with functions, but it's like the angle, right? It's like x is the angle, y is like the trig value, in this case the cosine value. But that 1/2 is multiplied by x before I do the cosine function, okay? What that number does is it changes our period, and it does it in this way, 2 pi over b. So when I see that b is 1/2, by the way, we're kind of doing one thing at a time. Notice out front there's no number. A would be 1, right? So the amplitude on this one has not changed at all, okay? I've only changed the period. But your period would be two pi over b, right? Now this is a little bit different than amplitude, where like amplitude is the number that you see for a, right? So in the last 2 examples, if a was 2, the amplitude was 2. If it was 1/2, amplitude is 1/2. Not quite like that with period. It's tempting to say, oh, the period is 1/2 because b is 1/2. Not so much, okay? It follows this equation you have on the top, right? I have to do a little bit of number crunching here. 2 pi over 1. Really need to switch that to multiplying by 2. Okay, and for this particular trig function, the period has changed to 4 pi. Okay, so again, I'm going to put the original cosine curve on here, which would start here. Right, now here, I could just keep that pattern of down to 0, bottom out. Right, so here's 2, this is what I was saying by 2 periods. These are kind of blurry and hard to see. This one right here, that's saying 2 pi, and this one right here says 4 pi, okay? So that's the regular one. Here's what's going to happen with this new one. We'll still start in the same spot. That hasn't changed. Okay, what I would go is over here, and I would mark at the very end. That's where my first period is going to come to a close. Okay, it's going to bottom out right here in the middle, and then I keep kind of dividing it into fourths essentially. Then right here I'll hit 0, and right there. Okay. Kind of like, all right, the period has doubled, so notice everything horizontally has just gotten stretched out by 2. But I like to go all the way to the end of the period and then mark that minimum halfway. So I saw that this one's going to bottom out at 2 pi. Okay. Let me back up to 4 pi by there. Okay. If I were to go a second one over here, there's negative 4 pi. Have a bottom out there, there, and there. Notice, relatively speaking, it's a much more long, kind of drawn out cosine curve because we made the period longer. That was the effect of B. All right, these next 3 slides, I got 3 more I want to do. Okay, well, for each of these, let's graph 2 periods. All right, so you can just kind of write that as the instruction. And I'm not going to do the original one anymore. I don't think there's enough going on here that I think we just need to focus on the new one. That's kind of up to you. You've got 6 examples. So notice on those 3, I drew the original, like the unchanged sine or cosine curve. Okay, if that helps, do it. If it doesn't, don't worry about it. Okay, but here's what we have going on. We've got a sine curve. A is 2. B is pi over 2. So let's take a look at our period. Kind of weird that it's got a pi in it, but it does something kind of significant for us. Okay. When you put a pi in it, you can switch the period to not be in terms of pi, right? Because notice on like basically every one of these that I've done, the period has been 2 pi or 4 pi because, I mean, that's going back to an unchanged period for a sine or cosine curve is 2 pi. What if I just, like what if for a particular word problem, what if I want the period to not be in the units of pi and it needs to be something like, I don't know, 4? We can do that. You'll see if there's a value of b that has pi in it, that's what's going on, is we're switching that period to some number that's not in terms of pi. Okay, so here's how I approach these. I look at my amplitude and I mark my max and I mark my min. Okay, so that tells me, whoops, somehow I lost it up here. 2 periods. And now I go along here, 1, 2, 3, 4, 5, 6, 7, 8. Right? I like to mark those points. Okay? So now with my sine curve, it starts in the middle. I like to mark that. And then right here at 4, I make a reference to myself, okay, that's when I have to be back at 0 with the completion of a period. Okay? Now with sine, we hit 0 again in the middle, hit the max right up here, and then the minimum right down there. And I think from there you have enough where you're like, yeah, at this point I can connect the dots. And there's a nice looking sine curve. Period number 2, I mean, once you have the first one done, the second one is pretty straightforward. It looks the same. It's just instead of going 0 to 4, you're going 4 to 8. This will be the kind of the typical expectation when you're producing a graph is to do 2 periods. Okay, just like that. All right, we'll do 2 more here. Got to bring this one down a little bit. I notice the function is just up in the corner, and then I'm kind of graphing it down in the bottom right, just to make sure I've got enough room to kind of get ready to graph. Because you'll see the way we approach periodic functions, we don't make a table. Okay, it's kind of like we create, and this will get bigger after the second day. We kind of make a profile of the function, okay? Right now that profile is really 2, maybe 3 things. I look at this and say, okay, the amplitude is 2. I look at the negative sign and say reflected over the x-axis. That one you may not need to write out, okay? The other thing that I want to write out is my period, which is going to be 2 pi over b, which is pi over 3. Two pi over 1 times 3 over pi. Okay, another one where I get the pi out of there and it just becomes 6. So then I go mark 1, 2, 3, 4, 5, 6. Now if I got to do a second period, it's got to be the other way. 1, 2, 3, 4, 5, negative 6. Okay? So again, when I say two things right now, you'd be looking at A for the amplitude and the period. You should identify what those 2 things are in writing and then mark it on the graph. Okay? It's kind of like that work replaces a table. All right, so cosine, we haven't seen this yet. All right, we saw a reflection with sine, but haven't seen it with cosine. Cosine normally starts at the top. If you reflect it, it's not. It's going to go start down at the bottom. So this one I know right here, I'm starting down there. And again, the next thing I like to do is to go over to 6 and say, yep, that's when I need to be back down at the bottom. The middle at 3 is when I got to hit the top. And then at 1.5 and 4.5, that's when I'll hit my zeros. And your cosine curve would look something like that. Again, once you got that first one, the other one tends to be a breeze because you're basically making a carbon copy of it. Exact same thing. There and there. And there you have it. There's negative 2 cosine pi over 3x. All right, last one. Again, making 2 periods. So again, think of this like replacing your table of values. Like we have a little bit of work to do to get organized before we go and put this, before we start producing our graph here. So B is 2. We haven't seen this case yet, right? Pretty much everything we've seen when we've kind of changed the period has been a small number. Specifically, they've been smaller than 1. I think we've seen pi over 2, let's see, 2, pi over 2, no, sorry, 1/2, pi over 2, pi over 3, okay? The theme those all had, well, technically other than pi over 3, we're starting to switch. The first 2, for the most part, we're making the period longer, okay? This one is going to be more noticeable. Technically, on the last one, it happened. We made the period shorter. It went from 2 pi to 6, but not by much. It went from like basically 6.28 down to 6, okay? This one's going to be more noticeable that it's going to be cut in half and go from 2 pi down to just pi. And these already have a scale factor on them, so I'm right there. It's kind of hard to see. There's 3. There's negative 3, right? Okay. So here's the thing. 2 pi is actually right here. Okay. So this one's going to kind of get squashed. All right. It's a sine curve. It's going to start in the middle. Right here. Okay, but here's pi. My first period has to be done by pi, which means it's got to go all the way up, touch the max right there, b back to 0, down to -3, and back to 0. Same thing for the second. Back to 0, down to -3, back to 0 at 2 pi. Okay? So that the bigger that number gets, right? Because in this case, b was 2. If that number gets bigger, right, you get this shorter period length, and the curve repeats itself really fast. Okay? Now, you just kind of follow the process for what we covered. You'll kind of get more in tune to that over time, right? Where you kind of look at it and you're like, oh, 3 sine of 2x. That's going to get stretched out to 3 and -3, and that period is really going to get shortened down, and it's going to repeat faster. If you're at the point right now that you're like, when I look at a sine curve, I don't see that right away. As you're getting started with this, that'd be pretty common. Expect that perhaps that's gonna come over time. That's all for day 1. Basically what to expect in day 2, we've got like more sine, more cosine. We got a couple more things that we want to do. Okay, really 2. But we'll stick with the sine and cosine curves, and we'll add those 2 new things.